Hello everyone, you're welcome to this channel and we are going to be solving questions on strength of material. Basically, how to deal with a Mohr circle, how to draw a diagram that will represent the information given to us in a Mohr circle. And in looking at that, we are going to look at basically two axes, which is what? I'm going to look at what? The X and Y axis. Now on the X axis, I'll be looking at the stress rather, which is represented on the X axis. So I'll be taking my what? My X axis as what? Plus, which is the right hand side here, just like this is the origin. Then I'll be taking my Y axis as what? The shear stress. This one will be what? The stress, the normal stress, while this one will be what? The shear stress axis. That means the stress against the what? The tangential stress. I'm taking this one as what? As the positive, and we'll take the what? Below the origin as the negatives. So in that case now, if this is what? Positive, you should know what this one should be. That should be negative. Then this is the origin. Then up here is what? Is the positive and down is negative. Now, let us take an element and let's use it to analyze it. Let's say this is an element, for instance. Now, this is an element. Now, this element, now, according to they say, a plane element of a body is subjected to what? Compressive stress of 30 watt or 300 megapascal in the XX what direction. So that means that, let's say this is what? Compressive that is 300 what? MPa, megapascal, and tensile stress of 200 megapascal. So in y direction, so that means this should be what? Down 200 megapascal, then up 200 megapascal. Now, having drawn this now, they said what? Each of the above what? Stress is subjected to shear stress of what? Of 100 megapascal, so that when it is associated with the compressive stress, it tends to rotate the element in an anti-clockwise. This is anti-clockwise, so it will rotate anti-clockwise. That means this is a compressive stress. Now, this compression and this tensile. And don't forget, compression is positive, negative rather. Why what? That is compression. Why positive is for what? Tensile. So in that case, it will move like this. This anti-clockwise. So head to head, tail to tail. This one will move like this. Then this will move like this. So this is what? 100 megapascal. So for you to move anti-clockwise, it means our star XY along the SY element of the plane element is what? 100 minus 100 megapascal. So we have minus 300, which is minus 300 megapascal as a compression, and we have the tension or tensile stress as what? Plus what? 200 megapascal. Now, having done that, now this is our element. So up let's take our A for example. Let's take one coordinate. Let's allocate coordinate for it. S is our stress, Y is our shear stress. So the shear stress is on the vertical, the what stress is what on the horizontal. The principal the stresses are on the horizontal. Now we have what, according to our coordinate system, X should be written first before Y. So that means the coordinate on the X is what? The stress, while the shear stress on the vertical axis, according to the question. Now this is what? Y, and this is what? X. Now, having known that, now what I want to do now simply is let me quickly bring out my parameter from the question. The first question says what? A plane element of body subjected to this. So that means minus 300 is what? Is in stress there. Minus because compression along the S axis. Okay. That is S. Okay. Then we have what this, let's take point B as what? Tensile, which is 200. That means along the S coordinate. Megapascal. Comma. Then we have what? The shear stress along the compression. This compression, don't forget this C and this T. So along the compression, what happened is that they said what? Look at it. They said each of the above is above stress is subjected to a shear stress 100 what? Megapascal. Look at the statement. So that when it is associated with what? Compression, the stress, it tends to rotate the element what? In an anti-clockwise. So that means minus 100 megapascal should be here. Then plus what? 100 megapascal should be here. So in this case now, we have what? Our parameter complete. All completed in this case. Now, having done that now, what we're going to do is to plot it on the what? On this graph. This is the what? The origin of the graph, 0, 0. Now, in plotting the graph, we are going to be very, very careful. We are going to be very careful when plotting the graph because this is a coordinate. This is also a coordinate. And in doing that, we are going to what? Represent each of them inside the graph. Let's take what? 300. Let's say this particular one. Okay. We take what? Let's take our measurement. Let's say we have what? Then this is what? 1, 2, and 3. Okay. And let's take also, okay, let me just extend it. 1, 2, 3. Okay. On the vertical, let me expand a little by making what? 1, 2, 3, 1, 2. On the horizontal, let me say 1, 2. Okay. Let me leave it that way. Now, this is horizontal. Okay. Now, having done that, now we have taken all our coordinates. We have taken all the coordinates and the what we have taken our what? Coordinate from the question. So what I'm going to do simply is to represent the parameter into the graph, the coordinate into the graph. Now, minus 300, that means negative here, stress. Please don't forget this is what? Why this stress? So negative, say 300. Let's take this is 100 minus 200 minus 300. Okay, then let's take this as our 100. Take this as our 100. So this is what? The point A, which is what? Minus 300, comma what? Minus 100. Now let's draw the second one, which is 200, which is 200 plus 200, then 100. So this is B. So which is what? 200 and 100. So you join it. That the next thing is to join the 2 points together. Join the 2 points together. Now, having done that, after joining the 2 points together, you have something like this to connect them. Now, we draw the circle. This will be, there's a point of intersection of AB. There's a point of intersection of AB, which we now what? Take as our center. Let's call it C. So it meets the principal axis or principal stress axis at point what? So let's say this is OX, or let's say XX. You understand me? So now we are going to take this one as the center point of the Mohr circle we want to draw. This will be our center. So we're going to take this point as the center of our Mohr circle. So that means when we are drawing our circle, you're going to take that as the center of the circle you want to draw. That means from this point to this point should be the radius of the circle you want to what? To sketch. So in that case, what I want to do now is to pick up a compass. I will improvise. Let's say this is our what? Our center. So I will improvise. So, sorry, this is what? This is supposed to cut here anyway. Let's say this one is here. So this is why this is the center. Just permit me like that. So this is the radius. I'm coming. Okay. Let us just adjust it a little. Let's leave it like that. I think we have something close to perfect. You understand, man? Okay, now this is the what? The Mohr circle now. Now, if you have gotten your Mohr circle like this, let me just do it this way. Now, what I want to do is what? That means that this is the origin, and this is the center. So let me locate this center. So that is the center of the Mohr circle. This is the origin. Now from here to this place is the radius of the Mohr circle. From C to B is radius. Let's call this one N, and let's call this one M. So now, for us to solve, what do we start with? Now, don't forget that this is 100 megapascal. This is also 100 megapascal. Okay? From this point, don't forget, from here, which is from here to this place, is what? according to our graph, is 200 megapascal. Follow up from here to this place is from the origin, which we use to draw this coordinate and follow the coordinate up again, 0,0. And from here to this place is what? 300 megapascal. Okay? Having done that, from here to this place. Now, this is a mid, from this point M to N, this become a midpoint. Don't forget, from here to this place is 5, Mn is 500 megapascal. From M to N. So if Mn is 500 megapascal, that means Mc should be equal to 500 megapascal divided by 2. And that will give us what? 250 megapascal. So from there to this place is what? 250 megapascal. So if from here to here is 250, which you have this, that means this what we have here will not be, because from here to here is 300, here will be what? 50 megapascal. In that is negative because it's already on the negative. So, and that means that we have got one answer there, what we call the average what? Average stress. Average what? Principal stress. The average is equal to what? Minus 15 megapascal. We have gotten that one first. We want to use to solve all the possible questions that we can. Now, having gotten the from here, that is this distance here. You know, from here to there is 500. From here to here is 200. From here to here is 300. All together to this point is 500. So to get this C is a midpoint to M and N. So how do you get it divided by 2? That's why we got our what? MC. So our MC is equal to Cn. Don't forget, it's equal to Cn. Okay? So now, since you have gotten that, the next thing to do is to what? Get your radius. These are radius. These are radius. And how do you get our radius? We use Pythagoras. We know here 100. We know here to be what? This radius from here to this AR, or let's say AC is equal to radius of Mohr circle radius of the Mohr circle. So we get what? R square using Pythagoras equals 250 square plus what? 100 what? Square. Therefore, R becomes what? Square root of what? 250 plus 250 square plus what? 100 square. The square root. I would have 269. Everything will give us what? 269.258 what? Megapascal. So this is the radius of the Mohr circle. In other words, we have actually gotten the maximum shear stress. So maximum shear stress is equal to R, which is equal to 269.258. Don't forget this one occur at what? 45 degrees from the principal axis. You understand now? Although we are going to calculate our principal what? Angle. You understand the angle to the axis. Principal angle to the S axis. So I will add it to it to know the direction. That will be all this. But let's go back to our diagram. Leave that first. Now, we have gotten our what? R, which is what? 269.258. Now we have gotten that. That means that R is equal to what? CB is equal to what? C, let's say Q. It's equal to CQ. That means from here to this place, which is radius. It's equal to CX. C what? Let me call this one P. CP. This point P. Now, having gotten that, now what do we need to get now? We need to what? Solve our what? Let's say something in the question. This average stress can be what can produce the principal stresses. Stresses which are what? Q1 and what? Q2. Q1 is here, I mean row 1 rather, and this row 2. You understand me now? How do you get it? You understand? You are going to, don't forget, from here to this place is what? Or from this place to this place is what? R. From here to this place is R. I mean from this point, center C, to this point is what? Your R. Now, how do you get your what? From its measure, your principal stresses is measured from the origin. This is the origin. But there is a shift in this back, in this particular one. So what is the shift now? First of all, we know from here to here, this is your Q what? Y. While this one is your QX in this case now. So to get Q1, what we're going to do is to get Q1, I can clean the diagram. Don't forget the question. They said it rotates 30 degrees. So I don't know. Let's clean this part. Okay, we have represented it. Let's clean this part first. Okay, let's just wipe up this part. Now, since we want to get Q1 and what? Q2 first. To get Q1 is equals to what? 200, which is from here, no, sorry, from here to this place 200, from here to this place is, what do you call it? This is, from here to here is radius. From here to here is radius. So to get from here to here, which is our what? Don't forget, from this place to this place is Q1. So you remove this one from there, the average this. So radius is what? 269.258. Then this is negative minus what? 50. So what do we have? This minus, remove this one to get here. So what do we have? Don't forget this minus 50. This plus. So this plus from here, because we are moving towards this direction. Okay. So I want to have what? Now anything I'm calculating is from the origin to the end, which is what? So 269 point what? 258 rather, minus 50. So the principal stress is now what? 219. This is what? For the principal, the right hand side, that means major one of the principal stress. Then 2, the minor, or this one is due to what? Principal stress. Let me say due to tensile what? Stress. Put it that way better. This is what? Better presented as what? Principal stress due to what? The tensile stress. So megapascal. Then to calculate Q2. Q2 can be calculated by, look at it, from this point to this point is Q2. From here to this place is radius plus this. And it's going in negative direction, so minus what? 269.256 minus 50. You understand me? So in that case now, this what? Don't forget what this place is negative. From here to here is positive. And that's why. So in this one now is from here to this place like this. From the origin, here is minus. Then this one is also, we are adding this plus this. You understand? That means this particular one plus here give us from here to this place, that is Q2. And that will give us what? 25 what? 269.258 plus 50. Give us negative what? Minus 319.258 megapascal. What we have just gotten now is simply what? Minus because of what? It is due to what? Compression what? Principal compressive stress. Principal what? Stress due to compressive what? Stress. That's why the minus is coming out there. See minus coming out from the solution. Now, having done that now let's rotate to get the main question that we are asked, which is normal and shear stress when it's rotated. Now, we rotate what? They say the plane inclined at an angle. Now, if the plane inclined at 30 degrees, don't forget, there's what we call the plane elements. And there is what? More what? Circle. The Mohr circle. If the plane what? Inclined at 30 degrees, which is what? Clockwise, the Mohr circle will what? Will go 60 degrees. And what? This times 2 of whatever we have here. So that means if there is 40, the Mohr circle will go 60. You always times 2 of whatever the plane element angle is given. So in that case now, we are going to rotate it from where? From A. You shall rotate what? Clockwise. Because if you check the question, it tends to rotate the element what? Anti-clockwise direction. That is what? The stress. That's what they say. Say find what? This one now they say if the plane inclined at an angle of 30 degrees to the axis, that means that if you take 30 degrees, you are going to move from the maximum shear stress, which is from the bottom here, and rotate 60. Meaning that we want to have what? 60. Look at it. At an angle of 60 degrees. See now? Sorry. The center now to the center. So this is 60 now. So if you since you are saying with what? It inclined, the plane inclined at an angle of 30. The Mohr circle will incline at an angle of 60 from the what? This particular word initial position A. So if it inclined at an angle of 60, what does that mean? We have to find this place. So this one now give us a new what? What they call normal stress. This is a new what? This is normal stress. Let's call this one let's say V. So this is normal the shear stress, the new shear stress. Then this is what? The normal stress. So that is what we are going to do now. But most of the times our normal stress is measured from where? From the origin. So normal stress must be measured from the origin. You cannot measure it from it. So anything you solve here, we add 50 to it. So what we are going to do now is to what? Find the what? The shear stress first. How do you find shear stress? Now, first of all, solve this. This is equal to 2 theta. This is what? 2 theta P, which is the principal what? And the plane angle to the principal axis. So how do we solve that? So we are going to have tan. Why? Because here is opposite and here is what? Adjacent, which is 250. So it's equal to what? 100 over 250. Okay? So in that case now I would have 2 theta P equal to what? Tan inverse of what? 100 over 250. So what do we have? After we have rotated, we want to find here first, so that if we can get here, we can get this angle. This angle we are going to use to find here. Already we know the radius, so this is what we are looking for. So look for this part. So which is what? Now be 100 divided by 250. An inverse of what? So here is already 21 point what? 8 degree. So this one will now be what? What will be this? This one will now be we'll now remove it. Let me clean this part so that it will not be too rough. So there will now be what? Remove everything is 60. Remove 21.8 from 60. What do you have? Here will now be 38 point what? 19. 38.19. So that's what we're going to use to calculate our. So what you are looking at now is something like this. 38.19, which is what? Then we have the shear stress there. Then we have what? This is our radius. This radius. So you can now use that. And this is opposite this hypotenuse. So sine what? 38.19 is equals to what? Opposite tau Tn over R. So tau n will now be what? R is what? 269.258 sine 38.19. So what will be tau n? That will give us 269.258. Sine what? Sine 38.19. So 166.5 megapascal. So this is your normal stress or the shear stress when it's inclined to the plane at 30. Told you when it inclined to the plane element at 30, you will make an angle of 60 with the Mohr circle. Don't forget times 2. You understand me? So what is the principle here? If this one is theta p, this one will be 2 word on the Mohr circle. It's 2 theta p. This is angle to the principal word. Angle of the principal axis to the x, inclined to the principal axis, x axis. That means x, horizontal axis. Now, you have solved this now. You know you need to get the word, the normal. That means theta and normal stress. How do you calculate for normal stress from here? It's very easy. We use our SOHCAHTOA also to solve for that normal. Let me clean this part. So in this case now, we are going to solve for what? Using our what? This particular region, don't forget. So we are going to use the angle there, this angle, also, and this one to solve for this one. That is not the normal. We now add from, because the normal must be measured from the origin. So what do we do? What do we do now? Now it's okay. Sine what? Not sine this time around. Because 38.19 equal to adjacent over what? What is the hypotenuse here? Is what? 269.258. You see? Adjacent over hypotenuse. So this one, Qn will now give us what? Cos 38.19 times what? 269.258. So that will give you your normal what? Not normal, but will give you let's call this one MC. Let me call it MC first. MC. Give us MC first. So what is, because this MC to get MC. So this one now give us what? 269.258 and times what? Cos what? 38.19. That is 211.627 megapascal. But our normal should now be what? From here. Nobody is minus. You understand me? It's coming from this side now. So minus. So this one now will now be minus 211.627 megapascal plus, because our number should be from here to this new rotation where we measure when it incline at around 60, it will shift. Stamina. So it's now here that we're going to measure from MO. Let me put it MO. So that means plus what? Minus 50 megapascal. So that will give us, just add 50 to it. So 261 minus 261.6 megapascal. So if you still use your formula, maybe those of you that are watching me, use your formula, rho n equal to what? S plus y all 2 plus what? X minus rho y over 2 sine 2 theta, no, this cos 2 theta plus tau sine 2 theta. If you use that formula, this tau is along xy plane, which is 100. You use that one as minus 100 megapascal. Use your QS. Your QS is what? Is 300, which is I think is it compression or this? Okay, that should be compression. Yes, minus 300 megapascal. QY, take it as what? 200 megapascal. Now, when you do that, you are going to get your answer. Put all this one, this tau along the SY, you get normal stress. So you still get the same thing. If you use this one, tau n, that means shear stress, rho x, rho y, all divided by 2 sine what? 2 theta plus what? Okay, this is what? Cos 2 theta plus tau xy sine 2 theta. You are still going to get the same thing. This is for normal stress. You understand me? Now, if I want to calculate the resultant stress, I will have to draw it like this. So the resultant stress will now be what? I will trace this to the origin, which is this one will now be what? Because from here to this place, normal. Normal stress. From here to here is what? Is our, what do you call it? Shear stress. So this will be the normal stress to now balance it. So it now be looking like resultant stress. Then this one to the origin to O will now be what? This one will now be rho normal, while this one will tau. This one is V. Okay? So that will, if you want to solve that one, you just use your formula. Rho equal to what? Tau square plus what? Rho n square. You get a half question. If you use that formula to solve it, having gotten the value for this, what you are going to have is what? Minus 261.6 all square plus what? Plus what is that? What do we have for that normal stress? Okay, I think it's what? Plus 160 point what? Plus 20 what? 5 all square, then square root of everything. That will give us 310.09 megapascal resultant stress. We see how we can use small circle to get it. If you use formula method, you get your answer. You understand? If you use your formula method, you get your answer. If you use this formula method, you get your answer. If you use formula method to calculate what, you still get your answer after rotating 30. But in this case, now 30 times 2 is what? 60. Yes, 30 times 2 is 60. So you see now? So that's why we are using 60 in our Mohr circle. If not, we have a wrong answer. So in this case now, you have calculated your what? Then you can get the direction. You can get the direction. To get the direction, you are going to use what? Which one is that? We use what? Tau over n. That means to get direction of this, let me just clean this side. Okay. You get tau, the direction of what? For resultant what? You just use your normal tan phi equal to tau n over qn. You get your phi, the direction for resultant. Now, another thing again, that will be this part here. Understand? Because how do you do that? Opposite over what? Over adjacent. From here to this place, adjacent. Opposite, MO. So more or less like what? MV, which is this, over MO. MO is equal to what? Tan phi. So opposite over what? Over adjacent. So your phi will be this part here. This phi. Understand? Now, another thing again, you can be asked in the examination condition is that, okay, I've talked about what tau mass. We have talked about tau mass. So what is the angle to the plane? You can solve it from here. You can solve it, you can finish it up. The principal axis or principal stress. What is the angle of the orientation of the principal stress to the x-axis? This is it. That will be giving us about 100 divided by what? 250. Then divide by 2. Now only we having what? As 10.9 degrees. So that is the angle. You understand me? To the plane. But in the Mohr circle is 21 point what? 21.8. You understand, which is this angle that was solved. So I've been able to what? To try my best to what? To look at how questions can be maneuvered, how you can construct. This is your diagram for Mohr circle, which contain the details that you are supposed to use. You want to calculate stresses and all that. You want to calculate your stress due to tensile, stress due to compression, which is this side. I've explained everything you need to know for now. So till when we shall see again, please just press the like button. Have a wonderful day. Thank you.